I have a problem on multiple regression for us to look at this morning, and it has to do with a manufacturer of boiler drums, and they want to use regression to predict the number of hours needed to erect drums in the future. And just quickly looking over the problem, we have data on 15 boilers. They collected data on the response variable, y, which is the time it takes to erect the boiler. And the predictor variables, our x variables, were the boiler capacity, boiler design pressure, boiler type, and the drum type. Let's look real quickly at the data. And we've got, yes, I think, that looks like 15. And there's our response variable y. That's definitely quantitative. That's the number of hours it took. The first predictor variable, x1, boiler capacity, is definitely quantitative, and those are big numbers. Design pressure, x2, is also quantitative. And then we've got two categorical 0, 1 type variables, boiler type, x3, and drum type, x4. Okay, I'm just going to click on the little blue rectangle, and I'm going to click on Open in StatCrunch. Okay, StatCrunch opened, and we have our data with our response variable y and our 4 predictor variables. So I'm going to go to Stat, Regression, Multiple Linear. The first thing we need to do is select our response variable, our y variable, that's the hours, and then we've got 4 predictor variables, and I'm going to click on the first one, hold down Control, click pressure, boiler type, drum type. And we really don't have to do anything else to get this initial answer. We're just going to leave everything set the way it is. We are going to leave it as a hypothesis test because I think we're going to be asked about that a little bit later. And I'm just going to click OK. Okay, we've got our results here, and it gives us our prediction equation, our regression equation up there. What I'm interested in looking at the parameters, these are our betas, beta 0 and betas 1 through 4. These values here, rather, I should say, all of them are statistically significant, and our overall model is statistically significant. P is less than 0.0001, and we've got a F statistic of 112.91. We also can look down here and see our adjusted R-square, 0.97, which tells us that about 97% of the variation in Y is predicted by this model, which is pretty doggone good. So let's look at our problem. We've got to pick one of these answers there, and I'm just glancing down. Y hat is equal to minus 4625.1. Well, that's the correct for beta 0. Beta 1, 0.008192, which is what we have there, plus 0.20418, which is our beta x2, our beta x3, 4437.5, which matches that, and finally plus beta x4, 2043.1. So we would select that, and I'm going to check, and hey, I got the right answer. Okay, continue. We want to conduct a test for the global utility of the model, and we want to use an alpha of 0.05, and we need to set up the null and the alternative hypothesis. Well, in general, we're always saying that the null is that all of the betas are equal to 0, but the alternative is at least one of the betas is not equal to 0. And so, in expecting these, I think that's Charlie, C for Charlie, and we got that right. Now we need to get the F statistic, and I think the next thing they're going to ask us is for the p-value. Well, here's our results again. Our F statistic, 2 decimal places, so I think that's going to be 112.91. 112.91. Check answer. Got that right. And my p-value is 3 decimal places, so I think that's going to be 0.000. And let's see if I did that right. Yes. Okay, the appropriate conclusion. We've got a significant model, therefore we reject the null, and we can say there is sufficient evidence that the model is useful for predicting man hours, which is the erection time. Okay, the next part wants a 95 confidence interval for E of Y when we're given some values for x1, x2, x3, and x4. And we're being asked for a confidence interval, which tells me they're asking for a mean value of the function E of Y, as opposed to a prediction for a specific individual value of Y. So, there's a trick to doing this. The StatCrunch regression multiple dialog box does not have a way for you to enter these values of x1 through x4 that you need for the prediction, like the simple linear StatCrunch does. So you got to trick it a little bit, and I'll show you how to do that. Okay, we're going to go back to our data, and the way we get our answer, we're just going to enter in the values for the x1 through x4, 150, 000, 150,000 for x1, 500 for x2, 1 for x3, 0 for x4. So now we've added a data point. Note that I'm leaving the y blank because we want StatCrunch to give us a prediction about that and to also give us the confidence intervals around that. We go back to our output table, we click Options, Edit, and we bring up this multiple regression dialog box, leave everything the same. So now let's scroll down to the bottom, and we want to save some additional information. We want to make sure that predicted values is selected, and hold down the Control key, I want the confidence interval for that mean response, and I'm going to go ahead and get the prediction interval as well. We click on, this is going to save it into our data table, click on compute, and I'm going to close that out of the way for a minute. We now have a set of additional data in our data table. Our predicted value for that data point for y is 2062.847, and we've got a lower limit, 95% confidence of 1516.7, and an upper limit of 260901, or 0. It asks us to give the confidence interval to 1 decimal place, and we want, again, the confidence interval, not the prediction interval. I saved the prediction interval. Remember, that is if we wanted a specific individual y value as opposed to the mean of rerunning the test. And remember, the prediction interval is going to be wider, less certain than the confidence interval, and that's true. We can see the prediction is roughly 1100 to 3000 as opposed to 1500 to 2600. But anyway, we're going to go enter in here, and it's 1516.7 for 1 decimal place, and the upper limit is 2609.0, and I'm going to check my answer. Got that correct. The interpretation of the result is that we are 95% confident. Remember, if we repeated this sampling many times, that the mean number of man hours when X1, X2, and X3, and X4 have those hours are 15, 16.7, and 2609 between those values. So I'm going to select that, and let's see if I got that right. The last part asks what type of interval would be to use to estimate the average number. Average tells me it's the mean, and so that would be a confidence interval.